In this video, I wanted to take some time to go over the idea of what types of these expressions are reasonable and what you can and cannot combine using different vector operations such as cross multiplication, dot product, and then also division and stuff like that. And one of the motivations behind this is that it actually serves as a really good way to kind of like check your work and make sure that you haven't made any sort of errors along the way to make sure that what you're arriving at the end is actually going to make sense. So first, I want to begin by highlighting what you can and cannot plug into a dot product and a cross product, and then what you should expect to get out of it. So in the case of the cross product, for this, we plug in two vectors, and then we get back one vector. Okay, so very important, cross product output is a vector. Okay, in contrast, if we look at the say the dot product, we still plug in two vectors, but what we get out of it this time is just a number. Okay, so cross products give you vectors, and dot products give you numbers. Okay, so let's go through each of these expressions and see which ones make sense and which ones don't make sense based off of that. The way to approach this is to just kind of see, okay, look at what's in the parentheses, see what we get back. Does it make sense with the next operation? So with this one right here, this is our cross product, so we're going to get a vector back with it. And we are dotting this with another vector. So since we are taking a vector dotted with a vector, and dot products take in two vectors, this is an acceptable expression. So that one is good to go. We look at our next one, and it's actually kind of the same idea, except they've been flipped around. Again, the parentheses give us a vector. We have our dot product here. W is a vector. We're taking a vector dotted with a vector, and that is allowed. Our next one, though, might be a little bit of a different story. Because right here, our dot product, what we're going to get out of that is just a number. But we're still trying to cross that with a vector. And we aren't able to take a number crossed with a vector. Cross products require two vectors in order to be able to get anything out of it. So this is not a reasonable expression. Similarly, this right here gives us a vector back, or a number back, because dot products give us numbers. And we're still trying to cross this with a vector, which we can't do because cross products take two vectors. So this is not a reasonable expression. Looking at letter E, this right here is a dot product. So that's going to give us a number. And we're trying to dot that with a vector. And once again, dot products require us to plug in two vectors, just like with the case of the cross product. Taking a vector dotted with a number doesn't really make a whole lot of sense. So that is not a reasonable expression. Now these next two are a little bit different because they're not cross product and dot product. They're just looking at, okay, what are we allowed to divide a vector by, or how does that work? Well, in this case right here, I can take this and rearrange it as 1 over the norm or the length of W times the vector U, like so. Well, this is just a number multiplied by a vector. And since this is regular multiplication, we are allowed to take a number and multiply it by a vector because it just goes through and multiplies it by each component in that vector. So this right here is a perfectly acceptable expression. However, we cannot divide a vector by another vector. We do not have a definition for this kind of operation. So to divide a vector by another vector is not considered to be a reasonable expression. So again, the main idea behind this is just going back to, okay, what am I allowed to plug into things? What am I not allowed to plug into things? What do I get back after I've performed that type of operation? And then just seeing what kind of makes sense and what you're allowed to do with that. And hopefully being able to go through and identify these kinds of things kind of helps give you a stronger intuition for what you can expect to get at the end of maybe more complicated problems when you're working through your homework problems or looking at looking for a specific value. You can ask yourself, okay, did I perform this process in such a way that I did get the vector that I expected, or that I got a number like I expected? And this is actually particularly useful when you think about it in the context of working with, for example, the tangent vector, normal vector, binormal vector, curvature, all that stuff, where you have all these different quantities you're trying to find, and some of them are numbers and some of them are vectors. And you have to kind of ask yourself, okay, does this process give me the results that I'm going to want? So anyway, hopefully that's helpful in kind of developing that intuition for you, and that clears some things up.